Ladies and gentlemen, today I will introduce our paper DC-ShadowNet, Single Image Hard and Soft Shadow Removal using Unsupervised Domain Classifier Guided Network. Shadow removal from a single image is still an open problem. There is a hard shadow example shown in A, and a soft shadow example shown in B. Hard shadows are produced by point light sources with sharp boundaries. Soft shadows are produced by distributed light sources with blurred boundaries. The previous physics-based methods fail to handle soft shadows and achromatic surfaces. Supervised learning methods require shadow and non-shadow pairs. The current unsupervised method fails to remove soft shadows. Therefore, our main task is to remove both hard and soft shadows from a single image using an unsupervised method. Next, we show the network architecture of the DC-ShadowNet. The input of the network is the shadow image. Another input is the unpaired shadow-free image. The output of the network are the shadow-free images. Therefore, we have two domains. One is the shadow domain, another one is the shadow-free domain. Our shadow removal generator contains a domain classifier to classify these two domains. To train the DC-ShadowNet, we employ three unsupervised losses: shadow-free chromaticity loss, shadow robust feature loss, and boundary smoothness loss. We first introduce the shadow-free chromaticity loss. A shadow is a local change in illumination intensity and illumination color. Since the non-shadow region is lit by sunlight and skylight, the shadow region is lit by skylight only. Shadow will disappear in the shadow-free chromaticity image. Therefore, our goal is to obtain shadow-free chromaticity images that are invariant to lighting. The key to obtaining the shadow-free chromaticity image is to get the right projection direction. More specifically, at first we use entropy minimization to get the projection direction theta. Second, we use illumination compensation to get shadow-free chromaticity images. The lower part shows our shadow removal network. We compute the chromaticity map of the output shadow-free image. Guided by the shadow-free chromaticity images, the network learns to remove shadows properly. We show examples and the equation of shadow-free chromaticity loss. B, shadow-free chromaticity image, and D, chromaticity map of the output image. Our shadow-free chromaticity loss constraints, D, to be similar to B. Next, we introduce the domain classifier. Given the shadow input, the network learns to remove shadows. Given the unpaired shadow-free input, the network reconstructs the image back. We train the domain classifier to classify whether the input to the network is from the shadow or shadow-free domain. By distinguishing two domains using the global average pooling, the domain classifier is trained to learn the importance weights of the feature map. Averaging the weighted feature maps, we obtain an attention map. We show examples of attention maps in B. As can be observed, the attention maps clearly focus on the shadow regions. Next, we introduce shadow robust feature loss using the pre-trained VGG network. We can observe that features in B for the input shadow images are less affected by shadows, and they are similar to the features in D because of our shadow robust feature loss. Finally, we introduce boundary smoothness loss. From the input shadow image and generated shadow-free image, we can obtain a soft shadow mask. B is a boundary detection operation to compute shadow boundaries. C is the detected shadow boundary, and D is our output shadow-free results. Experimental results show that our method is effective in removing both hard and soft shadows. outperforming those of state-of-the-art methods quantitatively and qualitatively. Here we demonstrate some visual examples on the SRD, ISTD, and LRSS datasets. In conclusion, we introduce DC-ShadowNet, a new unsupervised single-image shadow removal network guided by a domain classifier to focus on shadow regions. We propose novel unsupervised losses based on physics, perceptual features, and boundary smoothness losses for robust shadow removal. To our knowledge, our method is the first unsupervised method to perform shadow removal robustly for both hard and soft shadows in a single image. Thank you for your listening. Our code and data is publicly available.